Doesn't seem to work. So
I will give him 5 seconds. 4, 3, 2, 1. Okay, he can come back if he succeeds to join us. District heating has until a few years ago been a secret in the European Union. It has not been on the agenda from our politicians in Brussels. But something has happened during the last 4 years. We have the EU Fit for 55 package with the aim to reduce the emissions of greenhouse gases inside the European Union with 55% by 2030. And here, for the first time, the politicians introduced the so-called system integration or sector coupling. That was the first time that they put focus on the possibilities to connect the district heating sector with the power sector, the waste sector, the transport sector, to minimize the total emissions of CO2. Then, as a consequence of the Russian invasion in Ukraine in February 2022, the European Union published the Repower EU back in May 2022 as an additional set of actions compared to what was already described in Fit for 55 package, where the development and modernization of district heating systems would be a good help to replace fossil fuels with sustainable energy in individual homes. There were also focus on the clean communal heating, that's also what we call district heating, and the possibilities to utilize surplus heat from industrial processes. And then at last but not at least, we had this recast of the Energy Efficiency Directive from last summer, from July 2023, where it's now an obligation for all municipalities inside the European Union, municipalities with more than 45,000 inhabitants, to prepare local heating and cooling plans. So now the frames are set from the European Union. We have no time to hesitate to get started with the development of district heating. The energy system we're looking into is a dramatical change from a system where we have had one directions between the sectors. We have had a district heating sector, a power sector, and a gas sector, and transport sector. The future system we look into is not a system based on centralized heat and electricity production, but a system based on the possibility to utilize local energy resources as surplus heat from industries, from data centers, utilize that in the district heating systems. So it will be a much more integrated energy system we are looking into. And that's exactly what we try to put on the agenda for this webinar this morning, where we have 4 different cases describing different kinds of system integration between district heating sector and other sectors. So if you are online now, Niels, I will give the word to you. Otherwise, I will give the word to the first presentation made by Mathias Vestergaard from Artelia, which is also a part of this TFE project, Poland. So are you here, Niels? Not yet. So I will stop sharing, Mathias, and then you can share. Okay?
Yes. So I will just start my presentation from the beginning here. Not sure if I can minimize this. Yeah. I hope that you can all hear me. Thank you, Lars. I will start just by a little correction to the headline. I'm talking about system integration of this Danish plant, but it's not a slaughterhouse, it's a processing plant, and I will come back to that later. But in general, I'm talking about system integration in two ways. Both the use of excess heat from the industry, but also implementation of electricity-based production. Just a brief introduction to who I am and who Artelia we work for is. We are a company located all over the world, but in Denmark we are at least 1,300 people working in three main areas, buildings, and of course energy and industry where I work, and infrastructure. We have more than 90 years of experience, and we were part of the engineering team of one of the first large-scale power plants in Denmark. We're situated in 8 offices around in Denmark, and if we look at the whole world, we are more than 9,000 employees located in more than 40 countries with offices and doing projects in more than 100 countries, so more or less all over the world. The case that I will be talking about is a case which takes place in the Danish city of Give, where a plant called Give District Heating is located. I think that Give is more or less a good representation of any given or at least a typical district heating plant in Denmark. So the first figure up here is the production that they had before we initiated this project. So most of the heat was produced on a wood chip boiler. So they have already made some progress towards less fossil-based production, but especially in the winter, they're still using a natural gas boiler in order to cover the heat demand. And they have the ambition to be 100% fossil-free, and this project will help them in that way. Also, they want to minimize the production that they have on the wood chip boiler, especially because it's considered as a transitional technology, because there's more and more demand on wood, and to some extent it's sustainable, but if we use too much, of course, we can't ensure that it's sustainable. So they want to minimize the use of wood chip. So in 2021, we started investigating the industry around Give, the city of Give, starting actually with a cake factory. But what we found out was that there was a low yield, a low output of heat, and the production was varying a lot. So, of course, the heat coming from this cake factory would be varying. And what I'll come back to later is that the demand that Give had was more a base load and constant production of heat. Also, there was possibility of sewage and wastewater, which could be cooled and use the low temperature here, but there was a low output here And same was for many other sources. There would either be a low output or a varying production, or the distance to the excess heat would be substantial. And actually, that was also the case for Danpo. But at Danpo, they have a high and constant output of this excess heat, a constant production, or at least a constant need for running these freezers, as well. We'll come back to later. But again, there was a long distance of approximately 4 kilometers from the Give district heating plant and the company or plant of Danpo. Then in 2022 and 2023, of obvious reasons, the energy prices increased, and a lot happened in the Danish government and the Danish heat planning. So all Danish district heating plants were encouraged to expand their heat supply to all nearby areas where it would be feasible. And this also included Give Fjernvarme or Give district heating to expand to the village of Far. And this village, Far, is actually where Danpo is located. So now it would make sense in both supplying Far with district heating and make the connection between Give district heating and the factory of Danpo. And of course, Far is only one of the villages and cities that Give district heating could expand to. So this expansion of the district heating grid also increased the demand for baseload production. So Danpo, it's not a slaughtering house, it's a chicken processing plant. So I think one of the most famous products is probably the chicken McNuggets, which they produce in large scale. And actually, the excess heat is not coming from processing the actual food. It's coming from these freezer houses and the refrigeration cycle used to cool these freezers. So what you can see here in the picture below is the evaporators or condensers that Danpo formerly used to dissipate all this heat. Just like a conventional refrigerator, if you put your hand on the back, it dissipates heat. It's the same here, just in a large scale. So they're using these evaporators to blow away the heat to the atmosphere. And also these fans within the condensers actually consume a lot of electricity. So the 3D model here is showing the heat exchanger that could be used to transfer this heat instead of using the free condensers. And you could cut off the power for the condensers. So for the factory of Danpo, there's also some economic gains to be made. This is actually the way from Danpo all the way to the consumers distributing heat. So we have to the left the freezer house of Danpo, and they have these condensers which blow air of approximately 10 to 20 degrees of heat out into the atmosphere. instead of using these condensers, we put this heat in a heat exchanger, and I will show you a map later, but the heat is then transferred from the Danpo factory to a building housing the heat pump. The thing is that the space or the area around the factory is more or less occupied, or the Danpo factory wants to save area for future upgrading their production lines and so on. So actually there was a need to find another location for the actual heat pump. So we have a closed system of two 400 millimeters PE pipes transferring this heat from the Danpo factory to the heat pumps. And the heat pump, of course, consumes electricity for the compressors and pumps, but otherwise it's only using the heat source of these approximately 10 to 20 degrees from the Danpo factory in order to increase the temperature in the district heating grid to approximately 65 degrees in the summer and up to 75 or 80 degrees during the winter. Now, in order to make an agreement with a private company such as Danpo, there's a lot of considerations that has to be made. Of course, what will the price of heat be? So you're exchanging something that may not be of value to Danpo, but you are making some interference within their production. So there will probably be a price of that heat. Also, the district heating had to consider how reliable this source of heat would be. In this case, the freezer houses will be running constantly, and they had actually plans of expanding the freezer houses. But as it is with any private company, the source of heat cannot be relied on 100%, as Danpo is on the free market as any other private company. So you have to consider what would be the outcome if Danpo decreases their production or if the company closes. That's many of the considerations that you need to make. But in this case, it seemed to be a very good match between the factory and the district heating. One of the primary demands of Danpo was that the production would not be interfered in any way. So in the system, there's made some decisions in regards to control. So if anything happens, a failure in the district heating, Danpo can always go back to running the evaporators just like they did before. And this is something that you need to be aware of if you make such agreement with a private company, because of course the private company has a lot of money invested in the production, and you need to be careful, at least interfering with their production. And we need to ensure a steady and a low temperature of return source water, as they need the low temperature to cool their refrigeration cycle. The map here to the right shows where Danpo is located in the city of Farre below, and the plant of district heating, GEO district heating here. Actually, as I said, the production from Danpo is more or less constant, but in the summer they actually have a slightly higher cooling demand because of the ambient temperatures and so on. So actually, in the summer we can produce more heat from Danpo, which is not really of interest to the district heating company, as we consume the most heat during the winter. So it's quite an opposite situation we have here, and that's also why we in this project made a storage, quite large storage, so that it can also handle future industries and excess heat sources, just like Danpo. So most of the heat in the summer will be transferred through this transmission line of 4 kilometers up to the GEO district heating central. Yeah, so the storage can actually deliver heat to more than 140 hours of continuous heat pump production. So we have quite a lot of storage capacity, and actually more than we need for this project. And of course we have some demand in Farre also, but the heat demand is around 1.5 megawatts, and Danpo at its highest consumption consumes about a half megawatt to 1 megawatt. And I will show the production of the heat pump in the next slides. Just to say that we have more capacity in the heat pump than needed to supply to the city of Farre and Danpo factory. This is a map showing that we have Danpo located here in the northern part of, or actually the picture is turned around, so it's actually the eastern part of Farre. And we have this red line, which is the line of this, we call it process water. It's a close line between the Danpo evaporator or condensers and the evaporators of the heat pump. I think it's around 700 or 800 meters. We're transferring this process water of 10 to 20 degrees, which is then cooled in the heat pump building and sent back to Danpo. And then we have the transmission line going all the way from the heat pump building to GEO district heating. And of course we have the distribution system for the Farre city to distribute heat to the consumers there. The heat pump is made of 2 modular heat pumps called H3000. It's a Fenergy heat pump. It's utilizing CO2 as a refrigerant. Could also be other refrigerants, but at this moment CO2 was the most feasible refrigerant, and these heat pumps were chosen because of the efficiency and the reliability. So it can produce around 5 to 6 megawatts of heat capacity. I actually think that it can produce more than 6 megawatts, I have a little sample from the commissioning, which is ongoing right now. So only one of the 2 heat pumps are in operation. But as you can see in the figures or in the graph, we are producing just above 3 megawatts of heat, 175 cubic meters an hour on this processing water line between Danpo and the heat pump. And the water coming from Danpo is at this very moment, or the exact moment of this data, 18.3 degrees Celsius, and we're cooling it down 5 degrees. I do not have the COP here, but from this commissioning, I was told that the average COP was around 3.7. And to compare with an air-to-water heat pump at this very moment, with these conditions, the COP, or the average COP, would be around 2.99 over the year. So by utilizing this excess heat, we are increasing the efficiency quite a lot. As the heat pump is utilizing electricity, we also have other factors. We have a quite good COP, but as you can see from this graph down below, the price of electricity could at some point be so high that you would not run the heat pump. I have included the yellow line is an electric boiler, so that's more or less 1-to-1 what you would get from utilizing electricity directly in the district heating production. Then we have the red and the green line, which is the current production units, the natural gas boiler and the wood chip boiler. And then at the bottom, we have the electricity taxes and the spot price covering the price of running the heat pump from Danpo. So we most of the year it's very beneficial to run with this heat pump, but we have certain hours during the year where actually the wood chip boiler is cheaper to run. So in these hours events, the operator of the district heating plant would have to choose between continue in production and at the heat pump from Danpo, or produce at the wood chip boiler. Would of course also be based on the demand at the given time from the city. But the district heating plant is bound to some Danish laws, one of them being the substitutionsprincip, which is saying more or less that heat should be produced on the cheapest production unit available, as long as it being socio-economical beneficial. So the main outcome right now from the project is that the heat pump is running at a very good COP, and as you can see here also, it is expected when both the heat pumps are running, they are expected to run as base load more or less constantly during the year. So right now seems to be a very good project for for Give District Heating. That was all I had.
Thank you very much, Matthias. I think if we have questions, we will take them at the end of this webinar. So I will give the floor to Niels Malmskjær from the Royal Danish Embassy in Warsaw. You have 45 seconds.
45 seconds. All right. Well,
Yep.
I'll start by
You are a
saying
busy man.
very much so. Hello everyone, and thank you so much for the invitation here. I think my role is to speak for less than 45 seconds, hopefully. As Lars said, the charts that you just saw and the transition you are going through is the important thing, not what I have to say. But I think it is clear to everyone now that Poland is standing in front of a lot of big changes. The heat strategy, which is coming any day now, will contain a lot of new demands, but also a lot of new opportunity for the Polish heating sector. And I think by being at this webinar, by engaging with the knowledge that Matthias and that Lars and that the Danish side represents, you have a opportunity to skip the line, to jump ahead, and to implement some of the most advanced district heating systems in the world. And the reason to install those systems and to make that big leap is not just so that you have a cool and new system. It's of course to save money and to save the consumers from being affected by all these price shocks that we've seen in the previous years. So I hope that you feel this sense of mission and this sense of urgency very closely and very cleanly as you are engaging with this knowledge and as you take it on board. And I hope that you call and write Lars at any hour of the day. He stands ready to help and to give you some practical guidelines on how to implement all these new technologies and what to do in order to serve your customers and your country the best. Thank you very much.
Good, thank you. I think I'll cut you off before you promise too much. Good, thank you very much, Niels. And then I will give the floor to myself with the next presentation. Here we have it in a few seconds. And that will be a case story about an orange. And then you'll probably think, what's the connection between orange and system integration? But you'll know that in the next 20 minutes. As mentioned, I'm representing the Vex company. And the Vex company is a district heating company in Copenhagen, responsible for the district heating supply to the western part of Copenhagen. We are established back in 1984, in fact 30 years ago, with the aim to utilize surplus heat from combined heat and power plants and from waste to energy plants. Today we are involved in production of heat and electricity as we bought a combined heat and power plant back in 2012. And we are also involved in distribution of district heating to end users in a part of our supply area. We are around 120 employees. We are part of the Greater Copenhagen District Heating Scheme, which consists of 4 district heating companies on the transmission level, supplying around 500,000 end users in 20 municipalities. And the total system has a distance of 40 kilometers from east to west, and I'm representing the company responsible for the district heating supply in the blue area. The Danish district heating history, that's in fact is the first step to system integration. System integration between waste sector and district heating sector. So the integration of renewable energy sources and system integration, it's not so complicated. In fact, it started more than 100 years ago, more than 120 years ago, in the area where DPDH has its office. And in fact, DPDH office is neighbor to the place where it all started. Back in 1903, where a waste incineration plant was built, the problem was that more and more people were moving to Copenhagen, and it was difficult to find free areas to get rid of garbage. Therefore, it was decided to build a waste incineration plant, utilize the surplus heat from that plant to heat a new hospital, and use the steam produced at the waste energy plant for cleaning equipment at the hospital. So this kind of system integration started back in 1903. We have developed the concept since. So the case I will focus on in this presentation covers more than these sectors, and it's a story about energy efficiency and the storage about an Orange, where we cover all these different sectors in this case. So what we try to make in this case is to make a horizontal integration of waste, district heating, electricity, natural gas, agriculture sector, the industry sector with utilization of process heat, the marine environment, and the transport sector. And how to do that, you can say it might be very complicated, and it is, but it's also simple when you have heard the history. It starts with oranges produced in Brazil. In Brazil, the oranges, they are juiced and oils are taken out of the peels. Then the peels are dried and they are shipped across the Atlantic Ocean to the eastern part of Denmark, to a city in the southern part of our supply area. Here you have the southern part of our supply area where we have our own combined heat and power plant based on 100% sustainable biomass.
So wanted.
Okay, I just continue. We have the CP Kelco factory where we utilize surplus heat. We have a gas engine and we have a biogas plant. What we have here is a public-private partnership between the CP Kelco, an American-owned company based in Atlanta, Georgia, and the VEX company, which is a partnership between 12 municipalities. So quite different partners here around the table. The CP Kelco company with 100% focus upon profit and very short payback time for their investments, and a district heating company with patient money, where we invest in projects with payback time between 10 and 20 years. The purpose here is to utilize surplus heat from the CP Kelco production, and what they produce is pectin, which is a product some of you have heard about it before. For some of you, it's quite new. It's a stuff you find in fruits, just inside the peels, and you use it to stabilize the viscosity of fluids. So you will find this product in marmalade, you find it in products from dairies, as yogurt and smoothies, and you even can find it in shampoo. During this process to get out this pectin of the orange peels, they create a lot of surplus heat, and until we went into a dialogue with the company, they sent all this surplus heat into the cooling towers to get rid of it. But we started a dialogue, look at the possibilities to utilize this surplus heat. We spent 2 years to make the contract and 1 year to fit together the pipes, and we established a connection to the factory you can see here. To the left, we have the process water from the company with a flow temperature of 75 degrees C, and then we have the return pipe from the district heating system with a temperature of 47 degrees C. Then we heat out the district heating water in a heat exchanger and increase the temperature from 47 degrees C and up to 72 degrees C. And part of the year, that's enough as flow temperature in the district heating system. In winter time, it's necessary to boost the temperature, the flow temperature from 72 and up to 85 degrees C, and we use that by using a heat pump. So we have a district heating flow temperature of 85 degrees C. At the moment, the heat production from this unit, from this factory, covers around 50% of the heat demand in the city. In the future, it will cover 1/4, 25%, because we are developing the district heating distribution systems in this area in the regime of Køge District Heating Company. Totally, we utilize 150 terajoule per year, and we have a rather high COP for this system here, estimated to be 18.5 when we made the final investment decision. And the background for this high COP is that a large part of the year we only use energy for the pump, for pumping water to the heat exchanger, and we do not operate the heat pump. Now we have been in operation for more than 4 years, and we can see that the estimated COP is not 18.5, it's more than 30, because we have been able to operate the distribution system with a lower flow temperature than expected and then calculated 4 years ago. And the consequence is that we have fewer operation hours of the heat pump than estimated. The agreement, the benefits for the factory is that they have now a good customer which takes heat all year. Their alternative to make this agreement was to cool off the surplus heating cooling towers. The benefit for us is that we have a constant supply of surplus heat, which in the next years will be relatively cheap heat, and that will support the consequence is that we will have a lower price for the heat coming from this factory than our alternative heat suppliers. For both companies, it was amazing to see how important the green footprint of this process was, even for an American-owned company. When they have taken out the pectin of the peels and we have utilized the surplus heat, the peels, they are brought to a biogas plant. And in this biogas plant, they are put 80,000 tons of these orange peels, 53,000 tons of manure from cows and pigs, more than 7,000 tons of seaweed from beach cleaning, and 60,000 tons of a byproduct from a pharmaceutical production. So all these raw materials, they are mixed together, and as a spin-off of these processes, that they generate a lot of biogas. This biogas is produced at the Solrød biogas plant. It's owned by the municipality of Solrød, and the municipality, they have signed a 5 years operation and maintenance contract with a private company. So they are not directly involved in daily operation of the plant. They are just owner of the plant. Then Solrød Biogas, they made the contracts to buy the raw material from the farmers. They contract to buy these orange peels and also this byproduct from the pharmaceutical company. Then they sell the biogas partly as upgraded gas to the national natural gas grid or network, and partly as biogas to our company VEX. And then they sell the degassed biomass to the farmers, and I will come back to that. So VEX, we buy the biogas, we use it in a gas engine, we sell the electricity from the gas engine to the power grid as green electricity, with an attractive feed-in tariff. And then we provide district heating for the transmission and distribution network based on the cooling of the gas engine. The raw material you can see here, it contributes to the total gas production in different ways. The primary production of methane is based on the materials from the CP Kelco. Around 75% of the total amounts of methane is based on these orange peels. But the rest of the raw material, it contributes to the production of biogas and to the afterward degassed biomass in different ways, and you will see that later in this presentation. You have a process scheme here, raw materials brought in from left. Then we have the biogas production, and to the right we buy the biogas, put it into a gas engine, produce green electricity and green district heating. So that's the output. And the heat production from this unit, it covers 1% of our total heat demand in VEX. The amount of surplus heat from utilizing surplus heat from the CP Kelco factory, it covers 1.5%. So totally 2.5% of our heat demand is covered by contracts in one or another way with the biogas plant and with CP Kelco. We have made an agreement with the Solrød biogas plant that we have invested in the gas pipeline and we have invested in the gas engine. If Solrød biogas plant decides to stop the delivery of biogas to us before we have depreciated our investments in gas engine and gas pipeline, we will be compensated for the remaining depreciation. So we have no risk there. We have a guaranteed production price out of the gas engine, which is linked to the cost for buying heat from waste-to-energy plants. So it's 10% lower than our price if we, as an alternative, should buy the heat from a waste-to-energy plant. So we have no finance risk in the contract. While Solrød Biogas, they have an upside on the biogas price. So no risk for us, but also no profit for us. But we have a guaranteed economy in this agreement. The gas engine, 3 megawatt green electricity to the grid and 3.7 megajoule per second green district heating as output. When the biogas is degassed, it's brought back to the farmers where it subsidizes conventional fertilizer, and that's a big benefit for the environment. So it's circled back to the farmers, the manure they have brought into the biogas plant. So you can see more or less this biogas plant, it's an environmental installation which solves some environmental challenges, and then it has biogas or energy as a byproduct. So what you see here, it's important for the environment. We reduce the CO2 emissions dramatically. We reduced the amount of nitrogen and phosphorus, which otherwise from the farmers were washed out to the Baltic Sea, which would have influence of the environment in the Baltic Sea, both for us as Danes, but also for you as Polish people. So this is an example how we, with this concept, have integrated all these sectors. And when I mention transport here, it's because when they upgrade this natural gas, this biogas, and put it into the national natural gas network, this gas can be used for transport for heavy traffic. So to summarize, if we want to utilize this renewable energy sources, it's necessary that we have a well-functioning district heating system, because without such a system, we couldn't use the surplus heat from the production of pectine. We couldn't use the biogas in the most efficient way. So without a well-functioning district heating system, these huge renewable energy sources, they would be lost for the society. It's also important here to mention that it takes time to set up such a concept, which we have done here. The secret is that it's necessary that you have the fantasy to look at one process and see what byproduct or waste product do you have here, and for which process can this byproduct, this waste product, change to be a resource in a state of a waste product. But that's what we have succeeded with here. We have got cheaper district heating for our customers. We have solved environmental problems with the emissions of phosphorus and nitrogen, and we have reduced the CO2 emission. So all in all, a good project with a short payback time. So thank you very much for your patience, and I will stop dealing, and we will go to the next presentation done by Johan Sølhøj from...
Yes. And I'll just have to find out how I share my presentation. Just a minute.
Yeah.
Okay, you can see it now?
Yeah, it's fine.
Great. Okay. Well, my name is Johan Sølhøj Heinesen. I'm the CEO of Egedal District Heating, a very small district heating company in the middle of nowhere compared to the transmission systems. Okay, yeah, we were established in 2014 by the municipality. The goal was to provide as much district heating to the municipality as we could, and that was not a lot back then. Right now we are 17 employees, and 17, that's because we're expanding the network right now. We didn't sell a lot of heat in 2022, only around 24 gigawatt hours. But next year we'll connect around 1,200 houses. So we are connecting a lot of new customers. And I think by around 2029, 2030, we'll sell around 149, 150 gigawatt hours. Well, we are getting a lot of new customers, and I think the goal is to connect around 6,500 buildings, and a lot of them connect because we have a low connection fee. It's only 2,000 euros. That's cheap in Denmark. They know we provide green energy, but we are in an area where we didn't really had a lot of district heating, so it's new to a lot of the people living out there. And that's why we got a leasing model for the HRUs. I'll show you a little bit about that. And of course, they care about the price of district heating. But most people in Denmark are aware that we can't use natural gas anymore. We have to make a decision. Do we want an individual heat pump, or do we want district heating? And that's the choice that they have to make in the municipality where I work. It was one of the municipalities in Denmark who had the largest part of natural gas boilers for individual houses. Okay, this is why a lot of them think it's a good choice to choose district heating. We got that leasing model where we do all the digging. outside the house and get rid of the old boiler, and also heat pumps. People are moving away from their old heat pumps, and they want district heating instead of the heat pump. So we get rid of the old boiler and install an HRU, and we own it and maintain it, and they only pay a small monthly fee. So all they have to do is pay 2,000 euros to get a connection, and then we can look after the heating inside their houses. This is just a chart to show you the price of district heating compared to other heating sources in the area, and that's including everything, maintenance and installment, depreciation time. So on the left we have district heating in Egedal where I work, and you can see natural gas over here and individual heat pumps. So of course that's important for a lot of people as well. But we are out in the middle of nowhere. You can see the system Lars works in blue down south, and we don't really have a connection to anybody, so we have to look after our own production. This is just a chart showing you what happens when we install a lot of customers. Of course, we sell some more heat, and that is going up quite fast. And of course, we have to do a bit of work to make sure that we can supply heat for everybody. This is just a scheme of the network that we will have when we have connected everybody to district heating. Down in the left bottom corner, you can see a small plant that was built when the company started. It's running on wood pellets, and we have some solar thermal panels down there as well. And in the upper right corner, we have our biggest plant. We have solar thermal panels that we use in the summertime, and you can see our biomass building as well, and the storage tank that we have. And down in the right bottom corner, we have a small heat pump. It's situated down here, and that's running on wastewater. They have some lakes down there where they put the purified wastewater into, and then so we can have a steady flow of heat to the heat pump. It's a small heat pump. It's only 1.5 megawatt, but as you saw before, it's a very competitive price. So it has a lot of running hours. It will be cheaper than running biomass a lot of the year. This is just a chart of the price of electricity for a day. That's the 13th of this month, just to show you how much the price is varying over the day in Denmark. And well, we can run the heat pump all through the day because that will be cheaper than actually using biomass. We also have one small CHP engine left, and that is not being operated by us. Of course, we maintain it, but it's being put into operation by an electrical operator. So every time the price of electricity is high, and it is that sometimes, then they turn on the gas engine. So then we produce electricity for the grid and district heating for our network. We used to have 3 of them, but the 2 of them were too old, so wasn't a good business case to maintain them. So now we only have 1 left. Right now we are putting in a new biomass boiler. It's running on wood chips, and we are putting in some more storage as well. You can see the tank being built. Our wood chips are all from the local area, not too far away from Egedal municipality. So we have set up a supply chain with the owner of the forest in the area, and we are using the wood that is left over when they produce timber for buildings and timber for furniture. So we are, getting the wood that wouldn't be used anyway. Because we are expanding or doubling our capacity, we also have to get some more storage capacity. So that's the bottom picture. So we have to double that as well. The ashes from the biomass we burn is actually being sent to Poland now, and so it's going back into nature. It's being used to better the soil in Poland right now. So it is a closed loop. We don't have that many fields in our area that they can use the ashes in, so we're sending that to Poland. This is just a picture of the biomass plant, where you can see the storage tank we have right now. And of course, we are running that. They are looking at the price of electricity all the time. The guys operating it. So if the price of electricity is high, they are lowering the production on the heat pump, and then the biomass is taking over. But they of course they want to run the biomass plant on a steady production, and not too higher production. So we always have the cheapest possible heat in our storage tank. And that's the way all the small Danish company are using their plants, if they have biomass and other production as well. This is a scheme of our network as it will look like in 2030, with all the heat we need to actually run the network in a peak situation. And of course, the problem that we have is that we won't actually have enough heat. This is just a small tool we're using, where you can see that when we come into around 2027, we actually will be short of spare capacity, and when we move into 2028, we won't have enough heat for the coldest day. When we get to 2028, our peak load will be around 49 megawatt, and that will slowly go up. And this is just the picture when we look at the plant expansion, and that's the plant expansion, and there will be more. So we have to do something. So this is just a map of the two main cities that we are working in right now. You can see here there's a little map showing all the years where we'll expand in different areas of the city, and we are expanding.
Johan, could you go up to full screen?
It's not in full screen.
No.
No.
Okay.
Better now?
No, it's the same, but I can see you do what you can. Okay,
I'm doing
that's
what
it.
I can. Yes. Sorry about that. I hope you can see something at least. But this is just a map showing the areas that we are working in right now, and the picture up here in the right corner is what it looked like in 2021 when I joined the company. So what we are looking at right now is actually a connection. There'll be a connection to another district heating company, one of the transmission companies. I'll just go back and show you that. I didn't tell you about that, sorry. You can see we'll have a connection right here to another district heating company, and we'll have a connection up here to another municipality. So we are building those connections right now. So now we are looking at connecting this city out here. When it's yellow, it's still supplied with natural gas. So we'll do a connection from the pipe running out here of this small village and out here. So so what we'll do is that we will build an electrical boiler out here, because we have enough biomass and we have enough waste or district heating from a waste to energy plant out here in this pipe. So we can actually supply district heating for this city in the major part of the year. But in the wintertime, we will need more heat. And as you could see on the chart of the electrical prices, we can actually produce cheap district heating a lot of hours during the year on an electrical boiler, and it's not very expensive to build one. So we'll build one of those out here, and then we can supply district heating for this city. We are also looking at this area in the left corner. That's an industrial area. So they have some industries with excess heat. So I think during the next 2 years, we'll build a pipe down to this area so we can utilize the electrical or the surplus heat out there, and we'll build a heat pump or an electrical boiler out there as well. So that was just to show you that we are a small company expanding district heating a lot, and we have to. We are looking at the resources that that are best for us to utilize in the system. So right now we have decided to expand our use of wood chips, as we are getting from local forests in the area, and then we are moving more and more into using electrical energy as well. So that was just a very small story about district heating in Egedal and the integration of wood chips, electrical energy, and the use of storage facilities. Okay.
Good. Thank you very much, Johan, and for your timing of your presentation.
Yeah, that's fine, because I know I could see that you were short of time, so I had to speed up a little bit.
Yeah, fine.
Yeah, and I have to leave now. So if you have any questions, feel free to reach out. I know that Pia and Lars have my contact information.
Yeah.
So
Good.
Enjoy the rest of your day.
Yes, thank you, and thank you for your help.
Welcome.
Good. So I will jump directly to the last presentation. And that will be a presentation about a district heating company which is just born. So it's under construction at the moment, but it's still interesting when we talk about system integration, and especially when we put focus on the process from the first ideas, the step from vision to you can't see it? Is it visible, my presentation?
It works for me.
It
Yeah.
works. It's nothing
Okay.
happens.
Good. Yeah, okay, I just go on. Yes, as mentioned in my first presentation, we have worked with district heating and system integration since 1903. And today we are in a situation in Denmark where 64% of all homes, they are supplied with district heating. So it must be explained or described as a success. And district heating sector based on renewable energy is high on the agenda today, also in the Danish parliament. But we are not done yet. We are still expanding the district heating systems in Denmark. And this presentation will put focus on a new district heating company, the Bjæverskov District Heating Company, where a group of local citizens have taken the initiative to establish a district heating company from scratch. They wanted to phase out individual heating based on fossil fuels as oil and natural gas. And they have chosen a district heating based on excess heat from power transformation stations, from air water heat pumps, and from electrical boilers, and then a natural gas-fired boiler as backup. So here we have system integration between the district heating, between electricity sector, between natural gas, and again industry process. If you look at a power transformer as a kind of an industrial component where you have some excess heat. We are again in the eastern part of Denmark, and it's outside the Vækst district heating supply area. What's interesting here is to put focus on the first steps where we go from vision to action. Often we see a lot of visions in companies and in municipalities, and nothing happens. Here we have the initiative and the first idea taken by the municipality back in 2020 when they made their climate plan 2020. This plan is based on the targets set by the Paris Agreement and the goals set in that agreement, where there also from the municipality side was a strong focus on how we could involve the citizens in matters who were important and directly influence the citizens' daily life. And here the citizens in this small city, Bjæverskov, they were happy to look at the possibility to establish a consumer-owned district heating company as the best choice for this overall green transition of the city. Their alternative, it could be to phase out natural gas and oil and instead install individual heat pumps. But when they choose this scenario to establish a collective solution, they made it possible to utilize this exit heat from this large power transformation station in the city. The transformation system, transformer station, it's fact a part of the contact connection between Denmark and Germany, which is a 170 kilometers long high voltage direct current transmission line. It went into operation in 1998, so it's almost 30 years old, and it has a capacity of 600 megawatt and a voltage of 400 kilowatt. To utilize surplus heat from this power transformation station, then a collective solution based on district heating was the only possibility, because individual heat pumps, they could not utilize this surplus heat. So here they have to make a choice between a collective solution and individual solution, and they choose the last one. Furthermore, we have a connection from offshore wind turbine park in the Baltic Sea, the Kriegers Flak. And there we have a Kriegers Flak combined grid solution where we have a connection between Kriegers Flak, which is Danish, and the two German offshore wind farms, the Baltic 1 and Baltic 2, meaning that we have a cable connection between Denmark and Germany, connecting this wind turbine farms to both the Danish grid and the German grid. So that makes it possible, even if we have no electricity production due to low wind in the Baltic Sea, then we can still use this connection between Germany and Denmark to have a energy flow in both directions. That means that we, with this connection, can increase the competition in the power market and at the same time improve the security of supply of power to both the Danish customers or consumers and the German consumers. The timeline is that the first focus back in 2021, so it's only 3 years ago. The focus at that time from the inhabitants in the city, it was 100% environmental concerns about CO2 emission. So it was environmental concerns which were the driver for the idea and for the process to go from vision to action. And exactly in December, so it's 3 years ago, the municipality took contact to the Antlo Landowners Association in the city to start up a dialogue and to take the initiative to create a group of citizens with the purpose to establish this collective heating based on surplus heat from the power transformer station. So very fast, already 1 month later, they started this concrete work in this group. And then you can see step by step, focus changed as a consequence again of the Russian invasion of Ukraine in February 2022. The focus and on the benefits of this solution changed for not only being on environmental concerns, but now it was also a driver. How can we phase out natural gas as fast as possible to increase the security of supply to heating our city? And in summer 2022, this consumer-owned district heating company was established. Then through 2023, last year, they made different project descriptions, and they had a dialogue with the Danish Energy Agency. They applied for construction grants to the grid. They applied in April, and already in June, that means 2 months later, they have an acceptance from the Danish Energy Agency about grants for the construction of this new district heating pipe system financed by the District Heating Fund. So only 2 months from applying and until acceptance. Very, very fast process. And in August last summer, at the end of the summer, the project description, it was approved by the different departments in the municipality, and in October, the city council in the municipality of Køge, they approved the construction framework for this project. So a very fast process during 2023. This year, they have started to call for bids for the construction work. They have made a contract with the energy consulting company, and the municipality, they approved the sale of a piece of land for the district heating company's construction of production facilities. And at last here in June, the construction framework, it was approved by the Finance Committee and City Council in the municipality of Køge, and the contract was signed with the contractor. And in August, they started the construction of the pipe network, and during the winter 24-25, they will start the construction of the future heating plant. So an extremely fast process in a dialogue between municipality, inhabitants of the city, the construction of the pipe network. Totally, there's a potential for 1,000 homes, and now here in August, they have agreement, they have signed contracts for almost 90% of the homes. Amazing, and I'll come back to later what the secret is behind this success. And the total heat demand of around 24,000 megawatt hours. It's estimated that the excess heat from the transformer station will cover 1/3 of the heat demand in the city. The excess heat comes from cooling the valves of these transformers, and the hot water from that is approximately 35 degrees C, and then it's raised to 75 degrees C via an heat pump. So it's possible to use this flow temperature of 75 degrees C in a district heating pipe system. Furthermore, they have now under construction a working group which will focus on the possibilities to utilize more excess heat from this transformer, because there is also a possibility to utilize cooling of the transformer oil, and that could be a possibility in a later phase of this project. The last 2/3 of the heat will be covered by non-fossil energy sources. They establish air-water heat pumps, a capacity of 4 megawatt. And as mentioned in the first presentation by Matthias, here again it's heat pumps from the company Fenergy. They will cover 1/3 of the heat demand, and then they establish an electrical boiler of 11 megawatt to cover the last part of the heat demand, the last 1/3. Then they establish 2 natural gas-fired boilers for peak and reserve load production, and also to be sure that if electricity prices are extremely high, it could maybe be a solution to produce the heat based on a gas boiler instead. But as a starting point, the gas boilers will only be used for peak and reserve load production. To ensure that they have flexibility in the system, they also, the flexibility between heat demand and heat production, they also established a heat accumulation tank, a steel tank, 4,200 cubic meters. The one you see here is my own picture. It's a heat accumulator under construction in Romania. They start from the bottom and then they push it up. So that's the way we do it. And I know that sometimes it seems to be cheaper to construct this heat accumulator tanks in Denmark than it is in Poland. And we are joking a little bit with it, because then we have offered that we can re-import excellent good Polish labor from Denmark, so you can make your heat storage tanks cheaper in Poland than you do today. But I don't know if the circumstances will change, but at the moment we are primarily joking with it. To ensure that the district heating can be produced when the electricity price is low, even if it's here we have a system integration between the district heating system and the power system. And again, we see the benefits for both systems by making this integration of the systems. We have this primary model of the heat plant where we have the heat accumulator, then we have the building with administration with heat pump, electrical boilers, gas boilers, and other space for technology, and then we have the cooling fans. So relatively simple. To increase the economy in the project, they have decided to start up a temporary heat supply so they can supply the first connected consumers before the production plant is completed. And that means that they will be able to make a gradual commissioning of the pipe systems split it up in different zones over the period from now and until 2027. So they can connect these consumers as quick as possible and connect them at the same time as the street pipe network is established. The benefit for this concept is that the contractor only have to work around the customer's land plot once during the construction period. It's an advantage for the overall economy in the district heating company because it makes it possible for the plant to sell heat to the customers earlier than the budget behind the project, because it's possible to sell heat to the first consumers already in January 2025. And this temporary heat production, it will come from a natural gas-fired boiler in a greenhouse in the city. The economy for the customers is also important because their alternative to district heating was to continue with natural gas or to establish an individual heat pump. So they have calculated the running cost for this different kind of heating of the buildings. And they are more or less at the same level. As you can see, it's a little bit cheaper to continue with the natural gas-fired boilers than it is to convert to district heating or to heat pumps. But even that, more than 90% has decided to switch from natural gas/oil to district heating. And why do they do that? The background is probably that the district heating company, they have built up a district heating tariff where the upfront payment for the customers connecting to district heating is relatively low. The district heating company will take care of the investments in the heat exchanger installation. So that's included in the heat price you saw on the slide before. So the upfront payment for a district heating consumer is 5,000 Danish crowns. If you are in a situation with an old gas boiler and you need a new gas boiler, you have to invest 40,000 Danish crowns. And if you instead decide to go from individual natural gas to an individual air water heat pump, the investment costs in Denmark are between 100 and 120,000 Danish crowns. So that's probably the background for the success that the district heating company, they have set up a district heating tariff, which makes it very attractive for the customers to connect to district heating because the upfront payments, it's much, much lower than the alternative upfront payment if you decide to continue with a new gas boiler or if you decide to continue with an individual heat pump. So tariff structure here is very important. So integration of surplus heat from the transformer station, district heating, electricity, and natural gas is what you see in this project. We have had very close cooperation between the municipality, and the citizens in the city, and they have together chosen a system based on system integration between power and district heating system. They have spent less than 3 years since the first thoughts got on paper until the construction work was initiated. Very short time from vision to action. And then, not at last, but not at least, the Russian invasion in Ukraine has made it so important for people to reduce the dependence on gas and instead go on electricity. And here, the cheapest electrification of the heating in Bjæverskov, that was to utilize surplus heat from this power transformer station in connection with heat from air water heat pumps and electrical boilers. So it's also important that more and more people, they are leaving the natural gas system in Denmark, and that means that the remaining customers, they face increasing cost because now there are fewer customers to cover the fixed cost for operation in the natural gas system. And then it has been important for people to get access to green, reliable, and competitive heating prices, as they can do with this district heating connection. And what we see in many cities based on that kind of heat in Denmark, that the prices for houses, they are increasing. And that's, of course, a benefit from the homeowners just now, because there's an upside if they later are going to sell the houses. And this upside, that should not be underestimated. So that was all from my side. And then before I open for questions, I will give the floor to Mr. Ragulski.
Yeah, just a practical remark.
Thank you.
Before we give the floor to Mr. Regulski, we will invite the translator into the room so we can speak in Polish and we can hear the translation into English. So I will just do that.
Good. You just said ready when you made the shift.
Thank you. Bardzo dziękuję. Bardzo dziękuję Lars, bardzo dziękuję Pia, Matias i wszyscy, którzy dzisiaj brali udział w dzisiejszym spotkaniu. Dziękuję serdecznie bardzo uczestnikom, kolegom.
I would like to thank you very much. I would like to thank all the participants of the meeting.
Bardzo dziękuję za możliwość uczestnictwa naszej organizacji jako swoistego partnera tego programu, który jest skierowany dla ciepłowników z Polski.
And thank you very much for allowing our organization as a partner in this program targeted at the district heating sector in Poland.
Nie jest tajemnicą, że nasza współpraca z DBDH datuje się od wielu już lat i nasi koledzy ciepłownicy wielokrotnie mieli możliwość zapoznawania się z różnymi etapami transformacji ciepłownictwa w Danii.
It is no secret that our cooperation with DBDH dates back many years, and our colleagues from the Polish district heating sector had multiple opportunities to see various aspects and various stages of the transformation in the Danish district heating industry.
I tak na marginesie powiem, że ci, którzy najdłużej do Danii jeżdżą, to widzą, jak w tym czasie wiele rzeczy w ramach transformacji zostało zweryfikowanych.
And those of us who have traveled to Denmark for many years can see how this transition has been taking place and how many things have been verified during this transition.
Jak widać, to kolejna interakcja, kolejna zmiana, która też w Danii jest przeprowadzana.
And as we can see, we have yet another interaction and yet another change that is happening in Denmark.
Wszystkim uczestnikom chciałbym poinformować, że to jest pierwsze z 3 takich webinariów realizowanych w ramach tego projektu, który realizuje DBDH.
And I would like to tell all the participants that it was the first of the 3 webinars that will be organized by DBDH under this project.
Te webinary dedykowane są generalnie dla członków Izby, ale jak widać z listy uczestników, nie tylko członkowie Izby w tym webinarium uczestniczą.
This webinar is in principle dedicated to the members of our Chamber of Commerce, but as we can see on the list of participants, it is not only our members who participate in the webinar.
Ja myślę w związku z tym, że jest to ważne, że wiedza na temat nowoczesnych procesów transformacji jest szerzona w coraz większym zakresie.
And I think it is very important that the knowledge about these transition processes is distributed and disseminated to a larger extent.
Jeszcze raz chciałbym podziękować kolegom z Danii za przygotowanie tego całego projektu.
I would also like to thank once again our Danish colleagues for preparing the whole project.
Poinformować, że informacje na temat kolejnych webinarów oczywiście będą przekazywane w ramach naszych wszystkich kanałów informacyjnych, tak jak to było w przypadku tego pierwszego.
And I would also like to inform you that the information about upcoming webinars will be disseminated using our usual communication channels, like was as the case was for the first webinar.
Na następny spotkamy się dopiero po nowym roku, ale prosimy bardzo o obserwowanie zarówno newslettera, jak i stron internetowej, jak i mailingu, jeśli chodzi o kwestie tych kolejnych spotkań.
The next webinar will happen after New Year, so please follow our website and the newsletter with regard to the dates of upcoming webinars.
I na koniec chciałbym zapytać Pia, czy zgodnie z komunikatem na czacie te prezentacje będą mogły być udostępnione uczestnikom webinaru, czy nie?
And one last question to Pia. Will the presentations be available to participants of the meeting as mentioned on the chat?
Yes, I will share the presentations with all the participants. So
Tak,
we will have them.
Okay.
Udostępnię prezentację dla wszystkich uczestników.
Okay, thank you very much.
Thank you.
Good, thank you. Yeah, that was a lot of information during the last 1.5 hours. So maybe you have a few questions now, maybe you have more questions tomorrow, but as mentioned by Niels Malmskjær from the Royal Danish Embassy in Warsaw, you are always welcome to contact us.
Było to całkiem sporo wiedzy, które staraliśmy się Państwu przekazać w ciągu tej 1,5 godziny, więc być może macie Państwo jakieś pytania w tej chwili, ale być może jakieś pytania pojawią się jutro czy później. Jak Niels powiedział, przedstawiciel ambasady, w dowolnym momencie możecie Państwo się z nami kontaktować, jeśli będziecie Państwo mieli jakieś pytania.
It's my hope that you can use what you have heard in this presentation, not just copy it, but use it as inspiration for what you are going to do in Poland in the coming years.
Mam nadzieję, że będziecie Państwo w stanie wykorzystać to, co Państwu przekazujemy, nie jako wzorzec do kopiowania, ale jako pewnego rodzaju inspirację do tego, co będziecie Państwo robić w Polsce w nadchodzących latach.
Yeah. You have different political frames, legal frames compared to what we have in Denmark. We have done it in our way, you have to do it in your way.
Macie Państwo różne ramy, odmienne ramy prawne, odmienne przepisy w porównaniu do tego, co my mamy w Danii. My to realizowaliśmy i realizujemy na nasz sposób. Wy będziecie musieli to zrobić na swój sposób.
But we are here today and tomorrow for supporting you.
Ale jesteśmy tu zarówno dzisiaj, jak i jutro, jak i w przyszłości, aby Państwa w tym procesie wspierać.
Okay. Do we have any questions?
Zatem, czy mamy jakieś pytania?
Okay, it sounds good. It sounds that you have understand everything.
Wygląda na to, że Państwo zrozumieliście wszystko.
I have question, Lars. Sorry,
Yeah.
Lars, I have question.
Yeah. Come on.
Mam pytanie dotyczące wykorzystania ciepła ze stacji transformatorowych.
I have a
Jak to technicznie
question.
się odbywa?
I have a question regarding the use of heat from transformer stations. How is it done in technical terms? Pozdrowienia dla Ostrudy.
Cześć Maciej. Pytanie, czy to jest tak, że te stacje są na zewnątrz, czy one są zabudowane? To mnie interesuje. Czy to jest...
One thing interesting for me is whether these transformer stations are outdoors or are they, do they have any housing or building?
Yeah, I will find out and inform you as a part of the ongoing TFE project.
Dowiem się tego i przekażę wam te informacje w ramach naszego projektu TFE.
Yeah.
Dziękuję. Ostatnie pytanie prywatne. Czy jutro mamy meeting?
And one last private question. Do we have a meeting tomorrow?
Yes, we have
Yes, sir.
at 9 o'clock.
Yes. Okay. Okay.
Yeah.
Tak,
Very
jutro o
good. Thank you.
9:00.
Thank you.
0900.
One question.
Yeah.
If I can ask, how is average price of heat? Because we saw the average price, the electricity in Denmark, but how is the nowadays average price of the heat?
Pytanie dotyczy średniej ceny ciepła w tej chwili w Danii.
Is that a question to a consultant, Matthias?
I think
Pytanie do konsultanta.
it's difficult to say something average because even in Denmark there's a lot of difference between the district heating company of highest and lowest price.
I help you because you said that the price from the heat pump is 10% less than the waste of heat price. What is the level of waste of heat price? In this case, you show us.
Yeah, the level of that price, it's set by by the Danish Energy Agency.
Cena
So
jest tutaj ustalana w tym przypadku
from year to year.
przez Duńską Agencję Energetyczną, więc mamy tutaj pewne różnice.
Okay, but
Ja rozumiem, panie Andrzeju, że pan jest nieusatysfakcjonowany.
Tak,
z tym,
jestem nieusatysfakcjonowany, bo pamiętam, że cena ciepła, tak, pamiętam, że cena ciepła w Danii, no jeszcze tam 10 lat temu była 2,5 raza wyższa niż w Polsce.
I remember that about 10
teraz
years ago.
mamy cenę energii elektrycznej mamy na podobnym poziomie. Pytanie jest, jaka jest nominalna cena ciepła, no chociażby w Kopenhadze.
Okay, so I remember that 10 years ago, the heat price in Denmark was about 2.5 times higher than in Poland. But currently we have more or less the same electricity prices. So the question is, what is the heat price, nominal heat price, let's say in Copenhagen?
In fact, I don't know. We can include it in the mail which Pia will send out with a presentation from this event.
Możemy podać tę wartość w mailu, który PIA będzie wysyłać po spotkaniu z prezentacjami.
Yeah.
Okay.
Just to be sure that we know which source we use for this information.
Tak, aby mieć pewność, że wykorzystujemy odpowiednie źródło tej informacji.
Okay, Lars, but I have one commenter from Andrzej. Andrzej, ten problem był poruszany na każdej wycieczce przez ostatnie 20 lat i my się nigdy nie będziemy w stanie z kolegami z Danii dogadać, bo jak kolega widział, tutaj Matias przedstawił analizę kosztów dostawy ciepła u siebie i tam z jego wyliczeń wyszło, że koszt gigadżula wynosi około 40 euro dzisiaj. W tej najbardziej, jakby powiedzieć, optymistycznej wersji tego rozliczenia, ale są systemy, w kolejnym systemie koszt gigadżula spadł do 28 euro, więc to wszystko zależy od lokalizacji. Zawsze na każdej wycieczce tak było, że różnie było w różnych lokalizacjach.
Okay, let me translate. This issue has been coming up throughout the last 20 years of our visits to Denmark. And I saw from Lars's presentation, or from one of the presentations, the cost per gigajoule was about 40 euros. But then in another scenario or in another case, this price dropped to 28 euros. So it's very difficult to give a single figure. And this is why this issue has been coming up throughout all these years of our visits.
Yeah, that's right.
Dokładnie tak.
And it is complicated because we have 400 different district heating companies in Denmark with 400 different tariffs.
Jest to również skomplikowane, ponieważ mamy 400 różnych przedsiębiorstw energetyki cieplnej w Danii i mamy przez to 400 różnych taryf.
And all district heating tariffs, they are split up in a fixed part and a variable part.
I wszystkie te taryfy mają składnik stały i składnik zmienny.
So the total price for heating depends on the size of your building, your house, and the consumption you have. So if you're living in a big house with a low consumption, the price per gigajoule is relatively high. And if you live in a small house with a large heat consumption, your energy price per gigajoule could be relatively low.
I zależy to od wielkości budynku i od zużycia ciepła, więc jeżeli mieszkamy w dużym domu o niskim zużyciu ciepła, to cena za gigajoule może być relatywnie wysoka i odwrotnie, przy małym domu i dużym zużyciu ciepła cena pojedynczego gigajoula może być relatywnie niska.
Yeah, there's no secrets about the district heating prices in Denmark because from the price controlling committee, we have a statistic every year where we can compare the district heating price between all 400 district heating companies.
Ceny ciepła w Danii nie są żadną tajemnicą. Mamy Urząd Regulacji, który publikuje informacje na temat tych taryf i możemy porównywać ceny ciepła pomiędzy wszystkimi 400 przedsiębiorstwami ciepłowniczymi w Danii.
But of course, if you have district heating tariff where it's relatively cheap to be connected to a district heating company, the cost for this connection must then be included in your normal district heating tariff, meaning that you pay the real cost for this connection over the next 20 years. So if it's cheap to be connected, it's relatively more expensive when you look at the running costs.
Ale taryfy są skonstruowane w taki sposób, że opłata za przyłączenie jest relatywnie niska i ten koszt przyłączenia jest później pokrywany w taryfie przez kolejnych 20 lat, więc tak to jest skonstruowane.
But could it be relevant at one of the webinars we are facing here in the beginning of 2025 to look at different district heating tariffs and the consequences of that when we look at the resulting district heating price?
Ale możemy w trakcie jednego z nadchodzących webinariów zająć się właśnie, porównać ceny w taryfach w różnych przedsiębiorstwach ciepłowniczych i to, jaki one mają wpływ na ostateczne kwoty.
It will be very interesting for us.
Okay, good.
Verify this.
Yeah, I take that one.
Thank you.
Okay, przyjmuję te sugestie.
Good. Okay, then I won't steal more of your time today.
Okay, zatem nie będę już Państwu zabierał dzisiaj więcej czasu.
And wish you all a good heating season.
Życzę udanego sezonu grzewczego.
So thank you very much for your patience and your participation.
Dziękuję wszystkim Państwu za cierpliwość i za uczestnictwo.
Thank you.
Dziękuję bardzo.
Thank you very much. Thank you. Bye. Have a good day.
Thank you. Bye.
Thank you. Bye.
Bye.
Thank you. Bye bye.
Thank you, Pia. Thank you, Lars.
Thank you. Thank you.
You're welcome. Yeah.
Bye bye.
Bye bye.